So today what we're going to do is we'll see some graph related things in more detail. Instead of using just the base package, let us just go into ggplot and let's understand how it works. Won't take much of your time, trust me. So your BA class 1 and 2 is done. So I hope you guys are now experts on exploratory analysis. You can understand what's a categorical and what's continuous. So just we'll do a quick, very brief recap of all the things. How do you create a new Excel sheet? Windows is always confusing.
Control and
New. That's all. Okay. So, okay, without going into much details of it, I'll just say if I have categorical and if I have continuous. So the only statistics that can be applied here is frequency. Count, right? Count and count percent. Count percent. Right? Not more than that. The bird's eye view, that's I'm telling. If it is continuous, I can do a plethora of functions. Like I can go for central tendencies. What are central tendencies? Mean, mode, and median. Online guys, you need to be more active. I can go for dispersion.
standard deviation.
Yeah, standard deviation, variance. What all?
Coefficient of variance.
Covar, coefficient of variance, and variance, covariance, coefficient. What else? Standard error, correlation. Yes. These are no, not regression. So these are dispersions, and what else we can do? Of course, we can do frequency count here, can't we? No. Can we do frequency count? Doesn't make sense, right? You can do it, doesn't make sense. Yes, skewness, kurtosis. So these are the plethora of functions that can be applied to a continuous variable. Now coming to visualizations. If I want to quickly explore my data, so both these things, so whatever I'm talking about is exploratory analysis, right? In brief, of course, it has a lot of stuff. I have here. I'm doing chi-square test. If I'm talking about stats test, what statistical test you can do for categorical variables? Chi-square.
Yes.
What are you thinking about? Yes or no? We can do chi-square, right? Online guys.
Yes, we can do.
Yeah.
Actually, we do the chi-square test only on the
categorical. Yes. Online guys. Hello. Guys, are you able to hear me? Online guys. So why are you not answering? And coming to continuous, what stat tests I can do here?
T-test.
If I'm talking about sample data, I can go for T. Z-test for population. And analysis of variance.
ANOVA is on combination of category and complex.
Yeah, it is again a combination. If I have bivariate analysis or multivariate analysis, I can go for ANOVA and stuff. But okay, let's include ANOVA in both. Right? F-test, yes, you can do F-test on. F-test is again on categorical and continuous.
Yes.
F-test is the ANOVA.
ANOVA is F-test, right? Yeah.
F-test.
Yes. Again, even I'm confused. ANOVA and F-test are the same.
In ANOVA, we find the F value. And on the basis of FLU, we define the words of P and all.
But whatever it is, it belongs to a bivariate or multivariate analysis, not for a single variate analysis.
It's a bivariate.
Bivariate analysis,
Bivariate
which
or
involves
more than-
one continuous and one categorical variable, if I'm not wrong.
Yeah.
Which is fine. Now, yeah, you can go left is a subset of ANOVA. But both are not the same, if I'm right. Both are not one and the same. But in any ways, talking about visualizations, if I can draw a graph, what kind of graph can I draw? So for categorical and continuous, what kind of graphs can we get? It can be bivariate, it can be multivariate, but what kind of graphs can we expect?
Categorical, we can expect bar graph.
There are nothing.
Bar graph,
So for categorical, straightforward, I can have bar, I can have pi, not more than that. To be very, very honest,
bar and
bar graph and pie chart. Okay, let us talk about univariate analysis perspective first. I can have bar graph of frequencies, bar graph of frequencies, and same pie chart for frequencies. If it is a univariate categorical analysis, no, not line plot, Harshit. Line plot is not for categorical variable. Coming to continuous, I can have scatter plot. If I have scatter plot, I can have line plot, histogram, bar, box, whisker chart. I have a whisker chart, violin chart. Violin and whisker is one and the same, slight difference, but we won't be discussing violin charts now. I'll stick to whiskers. What else we can get? What kind of visualizations we can get if it is an univariate analysis?
Box policy and discussion.
This is pretty much it. If I talk about, so if I say univariate categorical, I can have these graphs. If I have univariate, I have univariate continuous, I can have scatter plot, line, histogram, whiskers, violin, and so on. Now let's talk a bit. I think, don't worry, I'll just discuss every of these graphs in details. But I hope you guys got the concept, what we are going to do. If it is categorical, if it is continuous. Clear this? Online guys? Okay. Now if I talk about bivariate analysis, how many types of bivariate I can have? How many types of bivariate I can have? I can have a categorical with another categorical.
Continuous.
Yes. So let me just take this to another place. Let's take it to this side. So categorical. Categorical continuous and continuous. So if I have two categorical variables, straightforward, I can think about only bar and pi. I can't go beyond this. The two categorical, right? Okay. Sometimes in Excel. Okay, Harshit, again, I'm not classifying as discrete or nominal. I'm just straightforward talking about any categorical variable. Sometimes you might notice, if you have done Excel or if you have seen these examples, you have two y-axis plots. Have you ever noticed it? Two y-axis. So if I have a graph, so straightforward, I can have one axis. So this is my straightforward graph. So I may have some scatters or lines or whatever it is. But sometimes it may happen that my graph would represent, so I'm on one y-axis and one x-axis straightforward. But sometimes you might notice there is second y-axis here, which will be representing some other variable. So let's say this part here, this below part here, is representing some frequencies f. It is representing a frequency f. So this first y-axis will represent one categorical variable. The second y-axis will be representing another categorical variable.
Didn't you tривariate on this?
Why tривariate?
Because we are taking
No, these are two variables. One variable is this, variable 1. This is another. This is just the counts or frequencies in the x-axis.
Primary axis, secondary axis.
Yes, more like primary axis and secondary axis. So this can be done, this two y-axis plots are a part of categorical and categorical analysis, but the use of these are highly depreciated. They're not much in use these days. Sometimes it is useful, but not in every case. F is not a variable, F is just the frequencies. F is not, we're not involving any third variable there, right? They are just frequencies. Got this point clear? Online guys? Every one of you? Okay. Just a second, there are some more doubts here. Let me.
The frequency will pertain to first variable or second variable, or
Cross tabulation, sir. Two-way cross tabulations. Haven't you done it? So the frequency counts are them. So that's what I said. Like whatever numbers I'm having here, corresponding to each and every element of first variable and second variable, I'll have two y-axis. So I have points corresponding to first y-axis, which will belong to one variable. I have points corresponding to the second y-axis, which belong to the second variable. Yes? So this is my two y-axis plot. Okay, let's not go into details now. Let me just give you the overview first. Right? That's what I said, Gitu. Let me just give you an overview first, then let's go to examples. So two y-axis plots can be done for two categorical variables. And if I have a categorical and continuous, what plots I can think of?
line chart will be possible.
Okay, I can have a bar chart with stacked and stacked or dodged bars. Like it's almost like so. You must have noticed bar charts like these, right? Lot of them. So these are stacked. Sorry, stacked or dodged. These are dodged bar plots. So this can be done. Yeah, these are dodged. Yes.
one is on the other, then it's a stack.
Yeah, one upon one is stacked. This is dodged bar plots. You can see quite a lot of them. We have encountered quite a lot of them, right? So this can be done on a categorical and continuous variable where one axis would be representing. In fact, this can be better used for a trivariate analysis. So one categorical variable goes, the continuous variable goes on your y-axis. Let's say I have sales, for example. If I have sales, I'm representing them on on the y-axis, and sales happens to be a continuous variable. Let's say this here is Chennai, the location. I have one more for Delhi. I can have one more for Mumbai and one for Kolkata. So I have my second variable which is categorical on x-axis. Fair enough, right? And the bars, the 3 bars here represent some other variable, like it can be store type, for example, apparel, electronics, and let's say what was the other? Apparel, electronics, and groceries. Okay. 3 categories getting represented over there. Whatever it is. So I have trivariate analysis, right? So bar chart is a better representation of that, if I'm not wrong. What else can we get for a categorical and continuous? We can't get pie charts. Because pi will represent, okay, I can get a perfect circle, but still, a pi will represent only 2 variables. If I'm doing a bivariate analysis, okay, if I'm doing a bivariate analysis, yes, pie chart will also make sense. So I know this is not a good circle and this is not a good pie as well. I'm not that good at drawing. But yes, imagine that this is a perfect circle and each one of these pi is representing some continuous variable, and I mean, like, the number represented by these pies are continuous variables, and the category that is being represented by those pies is a categorical variable. So yes, I can have a pie chart here as well. Pi if it is only bivariate, but not for multivariate analysis. I hope you guys are just getting a bigger picture of what these graphs are meant to be, right? If you want, I'll just repeat from the start. Please pay attention. If I'm going for bivariate or any multivariate analysis, bivariate analysis and beyond, so if I have 2 categorical variables, I can have a bar chart, a humble pie chart, and a 2 y-axis plots, which is mostly depreciated these days thanks to the statistical systems. We will talk about these things in terms of something called faceting. I'll talk about it, but as of now, let's ignore that. 2y plots. If I have one categorical and one continuous, I can get a bar chart, I can get a pie chart. Straightforward. Clear until this? Online guys, any questions that you want to ask? All of you online guys, any questions that you want to ask now? Okay. Now if I have 2 continuous variables, this is again straightforward. Let's say I have something called, if I have 2 continuous variables like stack chart. If you have seen the Dodge bar plot, the bars are side by side. In a stacked bar plot, the bars would be one upon the other. Like I had three bars side by side for a stacked for a Dodge plot. For a stacked bar plot, I'll have bars one upon the other. This represents, let's say, electronics. This represents apparel. and groceries. Instead of being side by side, it is one upon the other. Now, if I take, let's say, two continuous variables, sales versus operating cost for stores data set. Operating cost is that expenditure which you encounter when you're running a store. If you open a shop, the taxes that you have to pay, the rent, the electricity bill, that's known as operating cost. Let's say I'll call this O. Sales or profits, I'll call it P. I'll call it P for profits. So if I have two continuous variables, the only plot I can think of is scatter plot. At the first go, I can only think about a scatter plot, right? So two continuous variables, the only plot possible is scatter. Now this scatter plot can be further, drilled down. Like if I have bivariate, I can go for a straightforward scatter plot. That's it. Now, what if I have multivariate? Any guesses what will happen if I have multivariate analysis? Let's say I have profit and operating cost, and I also wanted to add electricity bill. I have a third column called okay, not electricity bill. Let's say tell me a third column, third categorical, third continuous column.
Margin.
No.
Incentives.
No. Okay, let's say I have operating cost, I have profits. Let's say I have third column called salaries. For a company, salary is also an expense. Like if I'm running analytics labs, let's say I'm running analytics labs, I have operating cost, which involves rents, bills, and let's say I have profits, and let's say I have third variable called salary, which is again continuous. Now, which kind of scatter plot can we have? What small change in scatter plot that we can get? Secondary, no. Scatter plot with symbols. We can do that, right? Let's say a triangle would represent operating cost. A dot would represent salary. We can have that, right? We can have such charts. But net, if I have two continuous or multivariate continuous variables, I can only go for scatter plots. Clear? Clear with this concept? Online guys, did you understand what I was trying to tell you? Two continuous variables or multiple continuous variables, the only plot I can go for is scatter plot. Yes, Gitu, you are right. Line chart can be one. If I have scatter, if I just connect those dots there, that means I have got a line plot. Simple as that. Right?
But line chart, I think the line chart comes into the category of categorical and continuous.
Why?
At the one end we have like a year, and the other one is a continuous variable.
So that's categorical continuous.
Yeah. Line chart comes in the category.
More than line chart, bar chart makes sense there over there. Like let's say I have profits versus year. Profits is continuous, year is categorical.
Yeah.
I have 5-year data and I have profits for 5 years. A bar chart would make more sense, right? Instead of a line chart.
I'm talking about the only line chart.
See, fine. Or like someone suggested bar line chart. Vaibhav suggested bar line chart. So a bar line chart would be more sensible here. Bar and line combination chart would be more sensible if I have categorical and continuous. So let's say, yeah.
It's bivariate. It's completely bivariate.
Yeah. See, you asked me a question about categorical and continuous, right?
Yeah.
So, or you asked me about how about a line chart between year and this.
Yeah.
So that's what I'm telling you. If I have profits versus year, I have 3-year data here, 2010, 11, 12, for example, and have profits across y-axis.
Yeah.
Because continuous variables, I have to place it on y-axis here,
Yeah.
right?
Yeah.
So let's say I have a bar for 2010 here, a bar for 2011,
Yeah.
and here I have bar for 2012. 3-year data. So bar chart holds good first. Second, now if we can connect these dots here, I have a trend graph now, which is almost equivalent to this, the small one. I have a trend graph. Okay, sorry. Uh, Excuse me. Let me draw it in another place. So a trend graph would be like this for the same graph here, right? But I can't see much of it. Like, yes, I'm getting some insights here. No doubt. I'm not denying that a line chart can be used for this case. But what I'm saying is a bar line chart would make more sense. I won't go for a simple scatter plot or simple line chart when it comes to a bivariate or multivariate categorical continuous data. That's what I meant to say. But yes, I'm not denying that I'm not saying that you're wrong. It's all about making sense, right? At the end of the day. Okay. It's almost like finding mean for a continuous variable. If seriously, if I have factors, it can calculate mean for a categorical variable, which doesn't make sense, right? What does mean for a year mean? Okay, all right. So what we will do in the next 15-20 minutes is that we will see how to get all these things done in R using plain R, right? So consider yourself lucky because SAS does this, no doubt. SAS is more robust than this, but you have to pay 20 lakhs for that. That's what is the licensing cost of SAS Visual Analytics.
We can export the data in Excel and we can draw.
Acha. All right. By now, like you have done considerably good amount of exploratory analysis as well. All right then. So SAS University Edition will not support all the features of SAS VA. Of course, it won't. But R has the power of packages. We have a huge arsenal of packages. So your first thing for today is installing packages, and you would be installing ggplot2 and plotly. I'm surprised by the less strength today. People might be busy with their holy preparations. Come on, it's just your old cloth that you have to use, right?
Yeah.
Your unused t-shirt goes as your uniform for your holy. Our holy. So there are 4 guys sitting in the classroom and they're wearing good clothes. They don't know what will happen after this class. And online guys are a bit lucky because you're not directly in touch with me.
You seem to be wearing a good shirt too.
It's fine. It's not my shirt actually. So I don't care. Anyways. So what I will be doing is, not for the holy part, but for the R part, what we will be doing is, I'll give you one example in base function because if you can look at session info again, back to class 1, I have something called graphics and GR devices, right? So these are the base packages given by R, which will give you graphics utilities. Clear, online guys? So we will be using some functions from this and look at our things, and we'll also be using ggplot2 simultaneously.
This is the base package.
Plotly is just a sidekick of ggplot2. Like with Batman comes Robin, so with ggplot comes Plotly.
There is some advanced function in Plotly.
Plotly is just Robin. Yeah, like the end of the day, it also has an access to Batcave, right? So it will also have some more functions along its own functions. But usually Plotly is just a sidekick to ggplot. Okay, let's get started. I'm loading these two packages, ggplot2 and Plotly. Now first what I'll do is I'll take a simple vector. I'll be taking a simple vector. Some random elements I have 10 to 20. So I'll make use of plot function. Let me maintain an Excel sheet for all the functions that we are going for. This is just intro, and these are functions. So here one means our example one. What is my input? Input is what input I'm giving here? Just a vector v1, random vector of 10 elements, 10 to 20, and I'm using a function called plot. Plot v1, simple. So plot is a function from the base packages. Let's see what will happen if I run line number 6. I'll get a plot. I'll get a plot of the values v1. This is the vector v1, if you can notice, on my y-axis. Always the data goes on y-axis. Y-axis will always contain the data, right? And x-axis will contain, here at least in this case, the x-axis is having index. Index as in positions. So first position here, position number 1, I have 10. If you just remember your Cartesian system, Cartesian plottings, come on. So if you remember your Cartesian plots, I have 2 points, right? In Cartesian system, if I take x and y as 2 points, I used to represent them as x comma y, right? Yes or no? This is what plot function is doing. First it is taking the position, first position, and in first position which element is present in v1? 10. That's it. It is drawing that. So this is what is happening in plot v1. Right? Clear? Understood? So what have we taken away from this? So by default, if I'm passing values, is taken in y-axis. So if I'm passing values, it is being taken in y-axis. That's it. Values or data are taken on y-axis or plotted on y-axis. Clear this? Okay. Now let's just move on and find some help for plot function. So plot function is generic XY plotting. If I have X coordinates, if I have Y coordinates, I can get a graph. That's it. That's what a plot function is about. Let us explore few options. One of which we have done. The Y coordinates. From passing a vector, it is being considered as Y. X is index or any other dependent variable. Acha guys, tell me the basics of your graph. If I have two variables, dependent and independent variable, yes, the dependent variable goes on which axis? Online guys?
Y.
The dependent goes on Y and the independent goes on X. So in this example, I have passed only one variable which by default went into y-axis. If I'm taking two variables, like let's say I have taken pressure and temperature. Pressure depends on temperature. So pressure is a dependent variable. It goes on y-axis. Temperature is normal. It's a varying factor. It's cause variable. So it goes on x-axis. Okay, perfect. Here I have an argument called type. So by default, I'm getting a scatter plot. This is kind of a scatter plot, right? If I'm not wrong. The plot that I have got here is kind of a scatter plot. Okay, let me just zoom it out. So this is a scatter plot. Now, if I go for type option, it's a bit messed up. So type option can decide if I can have only points, which is by default, or I can have lines instead of points, or if you have both, and so on. Some other options as well, which you can explore. Right? Also, I have some other options like main. Main gives me a heading. Main gives me a title or heading for my plot. Sub for subheading, xlab for x-axis labels, ylab for y-axis labels. Aspect for aspect ratio or the width and height of the graph. Clear? So let us try those options if you may. So I'll say plot. So by default, so x-axis is indexes, so I'm not specifying the x-axis here. I have only one data, which is v1, which goes to y-axis. Clear? Point number one. Point number two. Okay. Type. So type can be L. No, type is by default P, which is points. It can be L, which is for lines, and B for smart, which can be both, right? So let's say I'm putting it as B for both, right? Both lines and points. Now I have something called main. Okay, let me get this down here and let me take this up. Main for main heading, let's say a simple graph for data and their index points. This is my main title. I have xlab, which is x-axis label. I'll call it indexes. Index or positions. Ylab or y label. I'll call it the vector v1. Contents of the vector v1. That's all for the options. Now let us run these statements and see what our graph turned out to be an error. Argument x is missing with no default. Let's not pass it as y is equals to v1. Instead of passing y is equals to v1, I'll just pass it as v1. Let's see how R handles it. Now I think we have a graph. Yes. I have heading, I have labels, I have changed the nature of my plots. Yes? Clear with this? Online guys? Fantastic. Now let us try a second level of examples. We were passing only one vector. Now let's pass two vectors and see what will happen. I have created a vector called data, which has some elements. So what I will do in this plot function in line number 20 is, in x-axis I'm passing v1 which has 10 and 20. 10 to 20, numbers from 10 to 20, and data I have similar sized vectors. If you can notice, data and v1 both are similar sized, because it is again Cartesian plotting. It is simple Cartesian plotting. If I say x is equals to some vector, y is equals to some vector, it will be drawing graphs according to that, x comma y. So here x comma y would be 10 comma 12, 11 comma 34, 12 comma 55, 13 comma 66, and so on. That's the x and y thing what we can get. Online guys, is that clear? Okay, so let me run this plot function. So now look at it. Corresponding to 10, I would have somewhere here, some element here, which is 12. Corresponding to 10, I have 12 right here. So 12 is somewhere around below 20. So I have this. Corresponding to 11, I have 34. So 11 comma 34. 12 comma 40, 12 comma 55, and so on. The graph goes on, right? Clear?
Yeah.
What is happening inside? Okay. Now see, I'm just teaching you how to draw graphs. I have told you scenarios where you can encounter different types of graphs. Now it's up to you to decide. Depending on your analysis, it's up to you who will be deciding which graph you have to draw. All I'm telling you is how to draw those graphs. That's it. That's all. This kind of information, eventually you can get a hang of it. I have given you a brief overview of all those stuff. I hope my point is clear to everyone. Online guys. Okay. Now moving on, you can just go ahead and add some labels to it. So on. Now I have added these labels. The same thing what I have done for the previous charts. Just for your revision. How did I get, which argument got this my first plot? Main. Which argument got data? Ylab. The vector v1 xlab. My subtitle is sub. And how did I get line and points? Type is equals to B. Type is equals to B. Got me this. Clear? Fantastic. Excellent. Okay. Getting. Oh, okay. Was that recorded? Oh, fantastic. Okay. Chalo, carrying on. What I will do now is, I have given an example of two vectors. Let us just extend that to our data frames. Because at the end of the day, if I am extracting variables or columns out of data frame, they are still vectors, right? Yes or no? Online guys, yes or no? Online guys. I don't know if I have a lag or something, but I want you to be more active. I agree that there is a 15-second lag, but still, please be active. Okay. Now what I'm doing is I'm just getting my stores dataset. Remember the age-old stores dataset? In my example here in line number 40, this is similar to plot V1. So total sales, I'm just plotting it around. So this is just index versus total sales. How my total sales is faring across all the indexes throughout my data from row 1 to row n. How is my sales faring? Can show the trends, show a lot of things. So simple scatter plot that is. Business problem would be quite different from this. This is just an example. You might encounter a few more business problems where you have to draw one variable plot. Here, sales may or may not make sense. What kind of visualization I'm trying to get. I'm just telling you that we can draw a scatter plot with one column, and that is what we are getting here. Clear with this? All of you? Fantastic. So just modifying this graph a little bit. Total sales, ranges and distribution. So it says that my sales across the data, it is distributed in this way, the trends and all. Let's say my data is arranged according to in a chronological order. Let's say I have a data which is arranged month wise, and I have sales. I have my data from Jan till December arranged properly, and this is my sales data. I can make out which months, around which part of the year I have more sales, around which part of the years my sales were dull. I can simply make out with this simple scatter plot, right? If I'm not wrong. I can say at this part of the year my sales were good, at this part of the year it was getting down, this part of the year it is worse, right? If my data is according to a chronological order. Just an example. On x-axis it is just an index. If you remember this example of plot v1, let's take a simple vector v1 and plot it. It is plotting according to the indexes. So row number 1, because there is no row 0 here, right? There is no row 0 in data frame. Row number 1 corresponding, I have some value which is somewhere around 100 to 200. Let me see the exact value what I have in my first row. So total sales is 160. So this is what is getting represented here, 160. Yes? Okay. Now in my second example, what I'm doing is, on one axis, I'm taking sales. On my x-axis, I'll be taking operating cost. Total sales or profits depend on your expenses as well, right? So total sales is dependent variable, goes on y-axis. Fantastic. Agree or not, online guys? X is an operating cost, which is I'm not getting that word. If I can call this as effect, this is cause variable that causes the effect. So it is a cause variables or independent variable. It goes on x-axis. Yes. Yes or no? So more is the operating cost, less may be my profits, or less may be my total sales. So I have here on y-axis total sales, x-axis operating cost. This is almost equivalent to our second example of plot function. So first example was that. Second example, where my input is v1 and data. v1 went on x-axis, data was on y-axis. So similarly, I have total sales versus operating cost. So operating cost is independent, total sales is dependent. So total sales goes on x-axis. Yes or no? Good boy. Y-axis, and operating cost goes on x-axis. Fantastic. So how would my plot function look like? Plot y is equals to total sales, x is equals to operating cost, and other factors as well, labels and all. I know this will look very weird. Let me remove. Okay, this will look very weird because this data is not that cleansed. This data is not that cleansed, so it is looking a bit weird. Or if I can pass on sorted values. The reason why it is looking weird is because the data is not that cleansed. The data is not proper. So if I'm sorting both, let's say this is what I'm getting, what I'm ending up with after sorting my data, right? Total sales versus operating cost. Again, this graph is totally wrong because my data is not proper. Please remember that. That's why I'm getting a very weird graph. For the same example, let me show you one with a proper data. You know that R contains some internal data sets. SAS has also given you some sample data sets to work with, if I'm not wrong. Online guys, yes or no? Online guys, SAS and R, they both give you some sample data sets to work upon. Empty cars is one which you usually find across all the examples. I have something called pressure, a data which represents pressure versus temperature. Let us draw the same graph for pressure and empty cars. Acha, boys, especially boys, answer this question. It's regarding cars. So you can answer this question. What happens to your mileage if my weight of the car is more? It is less, right? More the weight, less is my mileage. So, okay, no offense to girls, please. In this era of political correctness, apologies if I have hurt anyone's sentiments. So just tell me, if I have a graph like this, a curve like this, what does it indicate? Is it directly proportional or inversely proportional? Why? With increase in yes, Harshit, yes, my choice. With increase in x, y is diminishing, which means it is inversely proportional. So if I talk about empty cars, weight versus miles per gallon, with increase in weight, MPG should decrease. So I should get a curve almost like this, right? If I'm getting this, then my thing is correct. So let's see that. So how do we do it? I'll say plot. X-axis, what should I take? Weight. Weight is the cause, right? Empty cars, dollar. I have a column called WT. So I have lots of columns here. Miles per gallon. MPG is the mileage. Number of cylinders, displacements, horsepower. Guys, what is drag for? Okay. Weight. Cusack. VS, I don't know what it is for. AM for automatic or manual. 1 for automatic, 0 for manual. Number of gears and number of carburetors. Cylinders, that is. Not cylinders, carburetors, yes.
For torque.
Yeah, torque. Newton meters. More the torque, more the pickup. Yes. Yeah, we watch Top Gear. Yes. So yes, let me take weight on x-axis and y. I'll have empty cars dollar miles per gallon. Yes. Right. Let me draw this. Ooh. So if I can just happen to draw a curve, how it looks? Isn't it looking like this? Inverse proportional, yes or no? Yes. So here we go. The practical use of a scatter plot. It finds out correlations. It finds out how a variable can affect the other. It can get out dependencies. It can show me the distribution. A scatter plot. A simple looking, an innocent looking scatter plot can do a lot of things. Clear with this concept?
Yes.
Online guys? Fantastic. Now moving on. So this was almost a bivariate analysis of two continuous variables. I hope my hypothesis is correct here. So continuous, I can go for a scatter plot. Yes? Fantastic. Just one second. Okay. Now, let us take one categorical variable. Okay, I'll give this example later on. Now what we will do is, the two scatter plots what we have seen till now, let us see them in ggplots. Let us see how to get that done in ggplot. Okay. If you remember, like in our school days, how do we used to draw a graph on those graph sheets, the 50 pies graph sheets? Like, we used to get those graph sheets first. Let's call them as canvas or the graph sheet that we used to get before, the 50 pies ones. On that we used to draw lines, the x and y axis, using that long steel scale what we used to have back then, right? The 30 cm steel scale. After that we used to draw points or points on the axis. Depending on what data we are doing, we used to manually calculate on intervals of 5, on intervals of 10, 20 or whatever that is, on 15, we used to draw those points, right? And what follows next is we used to count on those grid lines and just went on drawing graphs. It can be bar graph, it can be any kind of graph. This is how we used to do it manually, right? Yes or no? We all know this ritual, ain't we, online guys? Yeah, scaling and all. You remember this process, right, online guys? Every one of you. Now this is what ggplot will do. This is exactly what ggplot is doing. Now let's see how it is getting done. So like I have a plot function which is generic xy plotting in base R. I have qplot in ggplot too. So I'll just mention that over here. Plot function was for simple from the base package. From ggplot the equivalent is qplot. Qplot is generic xy plotting from ggplots 2. It works similar to my plot function.
Do we have another package, something like named ggplot? That is why it is named ggplot 2.
No. ggplot was the first release. ggplot 2 is the second release. So look at this line 101 and line 106. Do you find any difference? None, right? There's no difference, right, online guys? Except plot and qplot. The arguments and all, there's no difference, right? Output would also be similar, yes. So this is what a plot function is giving. This is the output from a plot function. This, ladies and gentlemen, is the output from ggplot. This is an output from your ggplot function. Clear? Agreed? So qplot is almost similar to plot function, generic xy plotting, pass x-axis, pass y-axis, and get your things done. One more example if you want. It's simple. You can follow that. Qplot x is equals to V1 y is equals to data. Here we go. Clear this, everyone? Any doubts? Any questions you want to ask?
The arguments are also passed in the same way.
Yeah, same way.
Main, type, and
I'll come to that. It's not that simple. All right. Line number 111 is almost similar to line 106. Sorry, 108 and 106. Okay, I'll just copy it here. 106, 107. So line number 107 is a bit matured way of writing arguments for qplot. Look at the difference between 106 and 107. It's a bit mature way of passing information to that. Oh my god. Alright, moving on. Let's get this done in ggplot. So ggplot works on layers. That's my first level of information that I know. First layer is the empty canvas, the 50 pies graph sheet. I'll draw axis. That is also part of my first layer. Almost. Third is plot, and it can have n number of other layers, fourth, fifth, and n, which are optional additions to the graph. Optional additions as in the titles, the labels, or combination of graphs like bar plus line, or point plus line, or histogram plus lines, histogram plus curves. So these are the layers in which ggplot works. First, empty canvas and axis. Next, the basic graph, and rest n layers from my second, third layer would be additions to my graph. Clear online, guys? All right. Let us see one example. Look at this function here. I'll break this down for you. First, I begin with the function ggplot, function from ggplot2. My first argument is data, of course. My first argument here is data, which is stores. Anything. Let me just stick to my stores dataset example. Or okay, if you want, let's take empty cars example, because you already have stores example here. So stores total customers, total sales. Here I'll take empty cars, MPG and gallons, MPG and weight. So data is empty cars. That's it. My first part is done. Second layer is axis, and my axis would be passed through a function called aesthetics, AES. AES for aesthetics or visual parts. And as a part of aesthetics, I have x-axis, I have y-axis. I have to specify what is my x-axis, I have to specify what is my y-axis. What would be my x-axis? The independent variable? Weight. Y-axis would be miles per gallon, the dependent variable. Yes? Clear? So this adds up a first layer. So I'll call it scplot underscore empty cars. Empty. Right? So I'll run both the statements here, line number 122, which is for stores, and line number 124, which is for empty cars. But I hope you have understood how this function's arguments are working. This is remaining as your standard. This should remain as your standard. Yes or no, online guys? Clear? Guys, fantastic. So I'll run both the statements there. Fine. Now let us see what are the contents. Let us print the contents of both. If I say SC plot for stores, look at this. This is almost your 50 pies graph sheet with your axis drawn and labeled. Yes? Agreed? So as this SC plot for empty cars. I have an empty axis. Weight, miles per gallon, and some labels. Now it's up to me which kind of thing I should be adding now. That's my second layer. Now it needs a little bit explanation, not much. Now, ggplot works on geometries. ggplot works on geometries, and geometries will specify which type of a graph I am trying to draw. I repeat, ggplot works on geometries, and that geometries will decide which type of graph I'm going to draw, and it's always referred by a family of functions which begins with geom underscore something. Geom underscore something. Right? So look at my help here. Look at the help. Please pay attention over here. Look at a list. I hope online guys are able to see it. Online guys, are you able to see this list? Geom underscore area, geom underscore bar. Any guesses what they are meant for? Bar for bar chart, area for area plot. Area plot is simple, like if I have a line plot, I'm just coloring that. That's an area plot. I have geom underscore box plot. Some of the familiar plots that we know. Box plot or whiskers, we know that, right? I have my density graph and density curves. I have frequency polygon, histograms. Yes, I have a histogram. So all these things, geom underscore line, somewhere it should be. Not AB line, geom underscore point, geom underscore line, C, D, E, F, G, H, and lots of them, some of which are not being shown on my screen as well. So geom underscore line, for example, line for line chart, geom underscore point for point chart, a lot of geometries. I'll give you a detailed list of all those geometries. I have a very beautiful book for that. Not I haven't written it, of course. Someone has written it, and I'm just using that. So I'll be sending you along with the reading materials. So please go through it. So all these geometries will be useful to draw. Some of the samples, of course, we'll be covering in the class today. Like in this case, if I want to draw a point or a scatter plot, I have to use geom underscore. Online guys, which geometry I should use for a scatter plot? Geom underscore points we need, right? So it should be geom underscore points. I need geometries for points. This is what it means. I hope I have not scared everyone. So point, geom underscore point, line, geom underscore line, bar, geom underscore bar. You don't have to take notes, classroom guys, don't worry. I'll give you this list. Histogram, geom underscore histogram, whiskers, geom underscore box plot. Online guys, is this clear? Fantastic. So what I'll do is, I have this original SC plot here. You know what it has done till now. And to that I'm adding another layer. What I'm adding? Which layer I'm adding? I'm adding a geometry, which is geom underscore point. So line number 136 is the next step for what we had done before. We have written ggplot function, data is equals to stores, aesthetics is equals to x and y something something. The next step would be adding the geometry. Yes? Agreed? Online guys? I want you to understand this concept. Rest all I can just skip and go on.
But can we specify the geometry on the above line also?
We can do it, but just for understanding sake, I'm doing it in two different lines. So gm underscore point, that's it. Now let me plot. Here we go. So this is what I end up with. Same thing as qplot, same output as qplot, but ggplot has given me, because it is doing it in a complicated way, which means I have more options to go on. On a simple level, you may not notice it, but when things get complex, you will uncover a lot of other options, almost similar to your as dot factor and factor, right? So I hope you guys understood till this point, all of you, classroom, online.
Why we are passing SC plot in plot sometime?
And I can just simply call SC plot.
Yes.
I can simply call SC plot. It will still draw a graph. Sumit, you don't have to use all caps always. All right. So that was our Batman. Let's get Robin. Plotly. So I have a function in Plotly called ggplotly. Now I haven't touched line number 138, Harshit. I was still 137 only. So till line 137 it's Batman. From 138 we'll go into Plotly function, and in Plotly package I have a function called ggplotly. I repeat, in Plotly package I have a function called ggplotly. Now scplot is a ggplot object. Scplot, it's a ggplot object. Yes or no? I have got it from ggplot function. If I'm passing it to ggplotly function from Plotly, I will get a graph like this. What's the difference? What kind of difference it has made? So ladies and gentlemen, welcome to interactive graphs. So as I hover my mouse, I get interactive elements. I am getting those elements. Like if I'm simply showing you this, you may not know what that is. But if I take my mouse to that point, I can know what it is representing. So how cool is that for a free software, right? So instead of paying 20 lakhs to SaaS VA and of course some licensing cost to your MS Excel, free stuff can do you this. Clear? ggplot functions. Is it clear to everyone how to draw a ggplot graph? At least for our practice and example sake, let us do the entire ritual with our empty cars again. So this is my empty cars data set. I hope you understood this line here, line number 141 here is clear to everyone. Online guys, what should be my next part? What should be my next part? Add geometry, and that's geom underscore point. Oh, shit. Guys, are you all able to hear me? Okay. So that's geom underscore point, and finally I will just plot that object. So this line number 142, and if I'm running line number 143, it is giving me a graph like this. Clear everyone? This is my ggplot, and to the ggplot object scplot underscore empty, if I am passing it on to which function? ggplotly, yes. Look at this, ggplotly is a function from plotly package. So ggplotly scplots underscore empty. So I get an interactive graph here. Yes? So we'll take a break. We'll take a break of 10 minutes and we can come back and finish the rest of the chapters. Alright then, we'll just come back at 12:15. It's 12:05. We can come at 12:15. Okay.
So ggplotly is just
Very quick recap after the break. ggplot works on layers. One layer will be creating an empty canvas and some points. Second layer will add, basically it will add the basic graph. Next layer onwards, it's just adding elements to your graphs. Combination of graphs or adding any titles, labels, everything will be done on the subsequent layers. So till here we have done a scatter plot, added points to it, geom underscore point will add points, and then if I can just plot it, I'll get a scatter plot done through ggplot. Yes, and if I use ggplotly, I will have, yes. So next two examples, what we'll see is next two examples, the same flow, within the same flow, let's try adding another geometry. So we had points, we will add lines to the existing points to add labels. Clear? Yes. So let us write the plot function for empty cars again, right? So scplot underscore empty. Yes, what was it? ggplot. Yes. Data. Online guys, go on. Empty cars. Aesthetics. AES. X is equals to weight. Y is equals to miles per gallon mpg. That's it. Yes. Plus. Next line I was like previous examples, I was just doing this scplot. Okay, let's do that. Scplot underscore empty is equals to scplot underscore empty plus geom underscore points. So this was our previous plot. Now, if I want to add lines to it, I would simply say, here I'll say plus. See, till here we have added two layers. So this, I'll call it layer 1. Then I'll call this layer 2. Okay, let us go layer by layer. Next is layer 3. Adding lines. How would I do it? Scplot empty is equals to, now scplot empty has points as well, right? Now I'll simply add geom underscore line. Geom underscore line, that's it. So first step, I have empty canvas. Here line 145 I'm adding points. So line number 147 I'm adding lines. Now if I happen to plot this, I can just run this function. I'll get both points and lines. Clear till this? Online guys? Is it clear?
you can also use pipe operator.
Pipe operator. It's for pipe operator is in your dplyr. It's in your plotly.
Okay. It's only in debug and deploy.
It works in dplyr plotly, but not in ggplot. Clear? All right.
Can we give geom point and line in
The same line?
the same line?
Yes. Geom line, geom point can be given in the same line. If you want to remove the complexity of adding more lines, you can do this. Or if you want to keep your code simple and keep on adding more lines, you can do like this, the one which I have done. Usually I advise you, when you're going for ggplot graphs, I advise you to go in this way. Because in later point of time, if someone else is working on your code, for them the debugging would be a bit easier. Especially given the fact that not everyone is an expert in R these days. So if you're writing simpler code, it's beneficial for the society. I'm serious, yes, of course. Open source is all about sharing and caring, right? Oh, come on, someone is giving you this for free. At least it's your moral obligation that you write a proper code with proper comments. So layer 4, add titles. Yes? So how do we add titles in plot function? Using an argument called main. To add title in ggplot, you need a function. So just say, I want to add title to my ggplot graph. The function is ggtitle. That's it. Why are you laughing at? Not everything I say is a joke. To add titles in ggplot, use ggtitle. That's it. The functions are easy to remember. Online guys, are you following, by the way? Fine. So plus gg title within quotes effect of weight GHT weight on mileage, right? So I'll run this. Fine. Now let's see what we get. We get a title, right? Simple. Looks complicated, but if you understand it, the process is simple. If I'm just breaking it down. Guys, the reason why I'm going very slow for all trivial topics is that your entire ggplot depends on this. Next up, I will be giving you a cheat sheet. You have to follow and do your graphs. I won't be taking any advanced graphs. I'll be leaving you here. Okay. You got this, how to put title. Now, I want to label my X and Y axis. Now, to add titles, use function gg title. Now, layer 5. Add labels to axis. To add labels to axis, I have a function called lab or label, abbreviation of label, lab. Lab is used to add labels. So again, the same ritual to the existing layers, add lab. I have x is equals to and y is equals to in labels. X-axis has weight, y-axis has mileage. I could not find functional lab. Is it lab? Labs. Oh, labs for labels. Not LAB, guys. I'm so sorry. Please correct it. I just beg your pardon. It's not LAB. It's LABS. Sometimes this old man also forgets it. So don't mind that. I'm not old. See, here we go. I have just renamed my axis labels. Clear until this? All of you? Online guys? That's it. And of course, your final step would be, no, this was Batman, get Robin, ggplotly. Yes, we have fully interactive graph, fully functional, fully interactive graph. Clear this? Okay. Now ask your SAS to do this without charging you license fees. No, right? Ask your Excel to do this. Yeah, it will do it. Drag and drop. You can just pirate your Excel. Now ask your Excel to do this on a larger data set. People who are fans of Excel, please do this for a 1 terabyte of data set, please. Would you? In Excel? So shut up and use R. Keep calm and use R. Okay.
So this ggplotly will work on basic package of plot.
No, that won't.
Yes.
Because is Robin a sidekick of Batman or is Robin a sidekick of Iron Man?
Okay.
So Robin is a sidekick of Batman, it will work. So on a very serious note, ggplotly is built for ggplot objects, not my regular plot objects. In fact, plot function is not creating any object. It is just drawing a plot. If you look at ggplot, if you look at my environment, it is actually creating some objects here. scplot empty, it is creating some objects. And on that objects, I can make use of it. If I'm trying to create an object from plot, it will give me null. Plot will simply draw. Fine? Okay. Alright. Now let's get into the other examples to say. Let's directly get into bar charts. Fine? So for that, what I would do is, just a second, please. Documents, datasets, stores, Excel sheet, stores. 5 of you sitting in the class. How many of you know Excel? All of you. Most of you. Online guys, how many of you have done in Excel? I think you must be knowing basic pivots, right? All of you are aware of pivots. Online guys? Okay. Hopefully yes. What does that mean, Vaibhav? Vaibhav? What does hopefully yes means? I'm not moving forward unless you explain what's hopefully yes. So you are through with concepts of it. That's what I was asking, which is fine. So hopefully yes, I understand. Just kidding, man. Just kidding. So, because even I also fall under Vaibhav's category, I hopefully know plots, pivots. What's the shortcut to insert pivot? Excel. Shortcut to insert pivot.
Control IP, I guess.
Control I, P, no. That's just changing my data.
Control to
Press escape. Yeah.
Okay. Insert. Insert pivot table. What I'll do is, my main motive here is to explain you bar plots, but I'll take example of pivots and explain you how to get bar plots done so that you can have a wider perspective of drawing bar plots in ggplot2. So this all I'll be accomplishing using dplyr in ggplot2, the grouping and all, and I'll draw a bar chart using that concept. Also, after that is done, we will just see how we draw frequency bar charts, a simple exploratory analysis. We have already used table function. How we can leverage the output of table function into a bar chart. We will see the complex things first and then go for simpler parts. So, okay. What I'll do is, I'll simply create location-wise sum of operating cost. Simple thing, right? And if I happen to insert a pivot chart, let's say I go for a bar, that's the recommended chart. Yes, of course. I'll get a bar chart like this. Right? Let's get this thing done in R. So give me an idea. Online guys, you can also give me an idea how to get this done. What would be my first step? My first step would be getting this table. Yes, my first step is summarizing. How to
creating label and summarizing. That's
yes,
the
summarize the table first. And then my next step would be create a graph. So those are my two steps what I have to do it in R. I hope everyone is following. To summarize a table, just go back. How do I summarize? Group by summarize. Yes, group by summarize is the only option left for me, sadly. And dplyr is one of the most robust packages which gives you best functions to summarize your data using group underscore by and using summarize. SE or ZE summarize depending on which part of the world you are. If you are from US, use ZE. Sarcasm intended. If you remember, if you rewind in the first class when I was talking about packages, I said dplyr and ggplot happen to be my most favorite packages. The reason is this. They give me a lot of functionality, a lot of unending functionality. Like if you happen to work on a real-time project, you would understand how convenient is dplyr and ggplot. Okay. So I'll use dplyr for group by and summarize, and I'll here use ggplots to package to draw geom underscore bar. To draw geom underscore bar, I'll use ggplot to package. That's it. That's all. Let's try to do it. I hope online guys you are following it. Nice. Nice. Where do we begin? Stores. We have stores. So identify the data. It's stores. Here what I'm actually doing, group by location, right? Agreed or not? Group by location. What do I calculate? Sum of total sales. Yes. What are the total sales across the regions? Help me with the code, please. That's the location wise sales is equals to, oh, first things first, library dplyr. So location sales is equals to stores. Yes. I hope you understand the use of this. Or you want me to write a full code for this? Do I have to write step-by-step code or should I use the pipe operator? Okay. Here not the majority but the weaker section wins. Let me use the step-by-step method. So first I'll create a temporary data set in which I will group by. So I will group by, yes, data is stores, and the variable name is location. So this contains my group by information. Next step, location wise sales is equals to summarize my summarize temp. My new column name is, let's say, here what it is giving in Excel, sum of operating cost.
no, only operating cost.
Oh, I'm so sorry. It's sum of operating cost. Sorry. So here it is, sum of operating cost is equals to sum operating cost na.rm, just as a safe side, na.rm is equals to true. Got it? That's it. If I view location sales, Yes, got it. Same output here in Excel. 129.5, 161.7, 174.8, 176.9. So my first step is done. Clear online, guys? So Gitu, the same step using pipe operator can be done like this. Location sales is equals to stores, the pipe operator, percent greater than percent, group underscore by location, again pipe operator, percent greater than percent, summarize, I'm from US. No, most of the projects that I've worked for are US clients, so I'm used to that. Local. So summarize sum of operating cost. Yes, will give me the same result. Clear? Okay, fantastic. First step is done. Now let us get to the plotting. Right? Identify few things for me, please. So online guys, tell me, not the classroom ones, online guys, tell me what does my y-axis represent? What is my y-axis representing? Yes, sum of operating cost. And x-axis?
Locations.
Location. Yes. So what? Huh? ggplot. Data is, what is my data here? What's my input data? Stores, right? No, stores. I'm working on stores data set, right? No. This would have been fun if classroom was full. Yeah, you see that confused expressions of people. People half sleeping. Yeah.
But today all the intelligence are sitting.
Yes.
Rest are
Be happy.
rest are celebrating. Preparing for Holi.
Preparing for Holi. So my data is location sales. In my aesthetics, my x-axis is x-axis is location. My y-axis is sum of operating costs. Fantastic. You guys are great, man. You guys are genius. Yes. Plus gm underscore bar. Here comes a small part. I'll explain. It needs a little bit of explanation, but first let me give it an object. I'll call location sales plot. This is my object name. Location sales plot. So to location sales plot, I'll be adding, for bar graph it is geom underscore bar. Yes, straightforward. So please look at this line number 74. I have a basic canvas ready. Yes, my canvas is ready. Just add a bar. To add a bar, I have gm underscore bar. Yes. Now let us run this.
Must not be used as bias.
Just look at the error. I have some error message here. I have an error message here. So what happens in geom underscore bar? I have three options for stat. I have an option called stat in geom underscore bar. An argument stat is equals to something. Represent the kind of exploratory analysis we are doing. Now look at operating cost. Look at operating cost. It's not count. We're not counting. In other words, sum of operating cost or count of operating cost is not a frequency. We are not getting frequency counts here. In other words, operating cost, my dear friends, operating cost is not a categorical variable. It's a continuous variable, and continuous variable does not have count. Stat count must not be used with y aesthetic. Y is a continuous variable. Count is for categorical variable. This is what is the meaning of this error. I hope you would have understood it now. Online guys, did you understand the nature of this error? My y aesthetic is sum of operating cost, which is continuous, and I cannot count because by default stat is count. I cannot use count for a continuous variable. It's for categorical variables. So here there is a small change that we need to do. We use stat is equals to identity instead. So whenever I have a continuous variable, I can use stat is equals to identity. I have to use stat is equals to identity. What does it represent? It represents that I am actually using a continuous variable in my y aesthetic. That's it. I did not run it. Here we go. You have a bar plot. When I have used stat is equals to identity, I get a bar plot. Clear with this? Online guys, clear with this? Good? Good for you. I hope I don't have to repeat all the steps again. You would have understood it? Yes? Okay, fantastic. Let us just go through some pre-compiled examples so that we will be clear with this.
So, does that mean that every time if you don't mention start equal to entry, it by default considers y aesthetic to be
No. It does not go for y aesthetic. By default, stat is set to count or stat is set to bin. By default, it is either of those.
So we have to
So that's an error, right? So that's why we have to change it to identity, because at least in our case here, it is sum of operating cost here. Okay.
But when you are using empty car data, where we are taking MPG value, and that MPG value was again like continuous data. So where we haven't.
Fantastic. That's a very good question. So if I have to do the same thing, see. Okay. If I have to draw a bar plot for our previous example, so ggplot data is equals to empty cars. Yeah. Aesthetics x is equals to weight, y is equals to miles per gallon plus geom underscore bar. If I say stat is equals to identity, so this does not make sense. A bar plot here doesn't make sense. It is just drawing some bars around. But what I meant to say is, if I have a continuous variable, it has to be stat identity or stat bin.
So this is only in case of bar plot.
This is only in case of bar plots. I think already someone else is. Vaibhav has also asked the same question. Yes, Vaibhav. This is specific to geom underscore bar, not to the other functions. Even this code, I'm just adding it for reference sake. I'll just add it here as a reference, and also the comments that I have written here, I'll be adding it to the main chart.
Identity or bin, both will work.
So bin is mostly for histograms. I'll explain histograms eventually, but bin is for histogram. 1250. Okay. We'll just look at some other examples quickly. Here, this was a straightforward example in which I have used two columns, one categorical, one continuous. Let us do this. What's happening? A new sheet. What I'm doing is I'll take customers, total underscore customers, with respect to store type and location. So location and store type. Yes, we can get it, right? We can get it. So help me out. What should I do to get this?
Group by two variables.
Yes. And this happens to be my bar chart here. Right? So, yeah guys, tell me, online guys, tell me, what should I group by here? Group by what? Location and store type. And summarize. What should I calculate? Sum of total underscore customers. That's it, right? So yeah, sum of customers. So that is what line number 235 is doing. Group by store type location, summarize, total customer is equals to sum of total customers. Clear with this? Fantastic. I'll run that. So here we go. Store type, location, count, right? Because this is Excel, it is displaying it in a very robust manner. The same table in R would be somewhat like this, but it, in any way it is giving the same level of information, right? Okay. Right? Chennai 508 apparel, all the 4 cities for apparel, all the 4 cities for electronics actually, and so on. Now, coming to the GG plot. Coming to the plot. So if you notice, unlike the previous case, can someone help me in just a second? Okay. If I want to get this, this kind of a graph in ggplot, firstly, this is a very robust looking graph, yes. So y-axis, x-axis will have store type, y will have my summarization, that is sum of total customer, and in labels or in this part, as a legend, I should get location. So this legend kind of thing, so X is store type, Y is total customers, sum, and I have legend. Legend is location. So to have legend in ggplot, I will use an argument called fill. If I'm using fill, it means that I am adding some column to the legend part. Clear with that? I'm just trying to equate the Excel and R. Is this thing clear online guys? X, I have straightforward X, Why I have straightforward Y? For legend I will use fill. Clear online guys? Guys, are you all there? So let's say X is equals to store type, fill Y is equals to location, this one, the sum of total customers, and fill is equals to fill is equals to location. Yes. Now I've added stat is equals to identity. Now as I have explained you before, I have stacked, I have dodged. So this example here is a dodged bar plot. This is dodge bar plots. Yes. So to get it done, I'll use an argument called position. So position is equals to, bless you, position is equals to DODGE, dodge. So that's my argument here to GM underscore bar. Done. And finally I have used ggplotly. This is Excel. This is R. Where is Excel? Yeah, here is Excel on one corner. And this, ladies and gentlemen, is R. Fine? Happy? You can explore more on this if I give you proper articles, proper materials, how to get stuff done. All of you, online guys, can you get it done?
Yeah.
Hopefully, yes. I think Vaibhav is almost my duplicate. Or maybe I'm a duplicate of Vaibhav. Because even I use that term hopefully quite often. Hopefully, हो जाएगा शायद. हो जाए तो अच्छा है. Okay, before we close, I will just quickly walk you through two functions, hist and box plot, because that is also important, right? How to get your histograms done. Pie charts and all I'm not covering because pie charts are simple extension of your bar plots. Use a function called pie or geom underscore bar and geom underscore axis. You can get pie charts done. I have given examples. You can follow that. Histograms are again simple. What do you mean by histogram? Okay, first of all, histogram is done for which variable? Categorical variable, right? Yes, histogram is drawn for a categorical variable. Online guys, histogram is done for online guys, which variable histogram is being drawn to? For God's sake, it's continuous variables which have histograms. No, not categorical. Guys, wake up please. A histogram is meant for continuous variable. Sumit, Vaibhav, it's not categorical, it's continuous variable. Good. Now what does a histogram do? So if I just draw a histogram of stores total sales, it is simply giving me the frequency distribution. Like, so it simply says from 0 to 100, from 0 to 100, there are 5 values which lie between 0 to 100. From 100 to 150, there are 7 values. Because total sales happens to be like total sales as min and max. Min, it will have minimum value, it will have maximum value, the range of it, right?
Yeah.
So there are 5 elements which are lying from 0 to 100, 7 from 100 to 150, around 4 values which are 150 to 200 and so on. One value between 200 to 250, 4 values each for 250 till 400, 4 values each, and one value from 400 to 450 and two within 450 to 500. This is what a histogram gives me. Frequency distributions for a continuous variable. If I just want to explain you this in layman's terms, I'm just converting my continuous variables to various categories, which in other words is known as binning. Remember binning? High value store, low value store. And so once I can convert my continuous variable into categorical, I can find frequency counts, right? Here also I'm doing the same thing. I'm converting my continuous variable called stores into various categories. Categories, that is 0 to 100, 100 to 150, 150 to 200 and so on. I'm converting them into bins. And then I'm finding my frequency counts. This is what is a histogram mean. Clear? Online guys, is it clear? What does an histogram mean? Good. So hist is a function which gets your histogram done. Yeah. What I'm doing now again is I'm taking a data set called links. Links is kind of a time series data set, but the main takeaway is this vector of elements here. The vector of elements. So if I happen to draw a histogram of links, the reason why I just randomly picked up links is that it has some numbers in it. That's it. There's no other reason. So you can explain me that. What does this mean? It means 0 to 1000 there are around 60, 61 or 62 values. So on. 1000 to 2000 there are around 15 values. That's it. Now one big takeaway is that point number one, I'm actually converting my continuous variable into bins, or I'm binning it. Yes, that's my point number one. Point number two, if I can create bins, I can also control the creation of bins, right? So you don't want 0 to 1000, you want, let's say, you want to divide it in other further ways. So to do that, I have two methods. I have an option called breaks. So if I say breaks is equals to 7 or 11 or something, if I can just run this. Yes, of course, other things remain constant like main label, X label. They're just theory part, you can just go through it. So you see, number of bins have changed. Like I have said 11, the original histogram is changed. I hope everyone is following this. Online guys, what argument did I change? I have changed my break argument so that my number of bins have changed. So this is my default one, what R is using. But if I said breaks is equals to 11, it will try to put it into 11 bins. But here is a problem. With breaks is equals to 11, I'm suggesting R to put 11 bins. But look at the output here. There is a small issue with it. If you can just count the number of bins, they are not 11, they are 14. Right? So there is a little theory around this. What happens internally is, if I give breaks is equals to 11, please pay attention. If I'm giving breaks is equals to 11, it is trying to create 11 bins, no doubt. But if there is any leftover data, apart from those 11 bins, it is trying to accommodate by automatically creating few more bins with same count, with same range of bins. It is trying to create additional bins to accommodate any leftover data. That's it. That's the reason why you have 14 instead of 11. It will take 11 as suggestion. So if breaks is equals to 11, the number of final bins would be 11 or more than 11, not less than it. I hope I made this point clear. Yes? Yes or no? Online guys. Is this point clear about brakes? Okay.
I have a question.
One second. Now, again, I'm not interested in that. I'm not interested in that because it is not actually giving me a proper control. What if I can create a range of bins according to my whims and fancies? Let's say if I have total sales, and I go for its quantiles, how do I go for it? If I go for it quantiles, stores dollar total sales. Let's say I want to create bins like this, 0 to 71, 71 to 120, 120 to 196. If I want my own custom bins, how should I do it? So this is how you do it. If you look at line number 341 here, 342 to be more precise. What I'm actually doing is, to my brakes argument, I'm passing a vector of elements, if you notice. Yes?
Yeah.
It is almost equivalent to your cut function. If you remember cut function, I have not covered in the class, but I have given you in the materials. A cut function would create brakes. Likewise, a brakes argument, if I'm passing a vector like this, it will create brakes. Please pay attention how it is creating. I have passed 0, 71.1, 120.8, 196.3, 230.7, 326, 472 and so on. 230 is the median, I guess. No, 230 is the mean of the data. Mean is not a part of your 5-number summary here, but mean have also added it. So 0 to 71.1 is my first category. 71.1 to 120.8 is my second category. 120.8 to 196.3, 196.3 to 230.7, 230.7 to 326 till I reach my maximum. If you can notice, I have used this max stores dollar total sales. Yes? Is this clear, online guys? I hope you guys are clear with this. Online guys, is this point clear? Every one of you. Apart from Vaibhav, Geetu and Sumit, who are most active or most inactive here. Fantastic. Now, if I am doing this, and let's see what is my output. Good software engineer always ignores warnings. So here we go. 0 to 71.1, 71.1 to 120.8, 120.8 to 196, and so on. I have created my own bloody custom, sorry for my language. I have created my own bins, right? Clear? I said Bobby, right?
Yes.
I have created my own Bobby bins. Yeah. Clear with this, every one of you? And that's, ladies and gentlemen, is histogram.
That we can represent the partition in that table, 0 to 196 like that.
The labels,
yeah.
That's your homework actually. That's your homework. The material that I'm giving you will contain the functions in which you can actually change the numbers here. Instead of 0, 100, 200, 300, 400, you can have your custom numbers. I have a function called access for basic plots. I have a few more additional layers for GG plots. You have to figure it out. I'm giving you the material, entire things. Come on, not everything I can explain in the class.
But is there any default number for break? Like someone mentioned break, the number there 76, someone missed that.
Default R will handle. R will handle itself, because if I'm not specifying breaks for total sales, it is still giving me some output, right?
So it will give me in one go.
See, look at this. If I'm giving histogram of total sales without giving any breaks, this is what I'm getting. It's doing it randomly. There is no logic behind it, or there might be some logic which I don't know. So that's why the break gives you more control. I hope we understand this. And one final thing is box plot or whiskers, and it's nothing complicated, but uh, box plots are going to be more essential in your linear and logistic regressions. Not for any purpose. The only purpose of box plots are to identify outliers. Okay, I'll tell you what. I have a function called box plot which can draw me a whisker. So I have taken this data set called US Judge Ratings. It's a inbuilt data set. Again, the reason for taking that is it has a lot of outliers. That's a proper data actually. It's names of some judges in US and some of the legal processes over there and their ratings in each of those things. This is what is the data is all about. But let's not get into details of the data. The reason I have taken this data is because it has a lot of outliers so that I can explain you the concept of box plots. So a simple box plot function would draw a whisker using some variable. So I have used the retentions R10 variable, RTN variable, RTN column, and I have got this box plot. This represents, this point here represents minimum. This represents, the bottom line here represents minimum. This here is first quadrant, 25 percentile. This here is median. There is no mean, that's median, the 50% of it. This is my third quartile, 25%, this is max. And these are the outliers. These are the outliers. Outliers can appear below minimum and above max. They can appear anywhere depending on the data. So this box plot proves that there are outliers in my data and I have to get rid of them at any cost before I can go for any kind of modeling. If I have outlier, you guys must be doing cluster analysis, right? Cluster analysis is placing your data into different categories. Yes? Simply to say. So if I'm doing any kind of segmentation, I'm supposed to get 10 segments, 10 customer segments. If I have had outliers, I may end up with one random segment, which I don't need. Yes or no? So for that, if I'm removing the outliers, I'm ensuring that whatever segments I'm getting are proper, are highly cleansed. So outlier removal is essential, whatever statistics you're doing. Fine. So identifying outliers can be done using whiskers. So if I happen to draw a whisker for the entire table, I can simply say box plots, US Judge Ratings, that's my table name. And here we go. I have a box plot for entire variables. So there are too many outliers everywhere. I have to get rid of them if I have to use these variables in any kind of statistics. Clear with this? All of you? Okay. I'll put an end to this class.